Assalamu alaikum and hello everyone. I'm Amir Shah from Adu High School. To begin with, let me first thank you for all coming by. In this very first lesson today, I'm gonna teach you all about indices. So let's get started. First of all, I would introduce you to the lesson objectives. Our objectives will be to use the laws of indices for all rational exponents. What this means is by the end of this period, you should be able to do all the types of problems involving rational exponents. So let's start with the basics first. There are two categories. The first one will be the basic index laws. You will see this kind of simple expressions, and the next level will be indices with fractional indices or negative rationals. So let's start. There are few rules that you need to know about indices. First of all, let me tell you what an index is. Now, when you have an expression like this, we have 3 to the power 5. That means the base, the one at the bottom, will be the base, which sometimes we call that is the expression 3 to the power 5. And the exponent here is 5. There are various names for this exponent. One of them is index. There is also the name power. In plural, we say indices. There are some few rules that we need to know before we start index rules. Some of them are the first rule. Let me state the first rule. Here we have when you want to multiply two expressions with the same base, then what you need to do is add the powers. So in this case, we have a to the m times a to the n. This will be a to the power m plus n. You are going to add the powers. If you want to divide two expressions involving indices, just make sure the base is the same. If the base is the same, then you need to subtract the powers. However, there are some cases where you have an exponent raised to another exponent. For example, a to the power m raised to the power n. This will be like bracket multiplication. You multiply only the indices together. You get a to the power mn. The next one is the last rule, which is AB raised to the power n, a product raised to the power n. What you need to do here is you need to bring the power inside to those two expressions separately. You bring n onto the power of a and n onto the power of b. So this will be read as a to the power n times b to the power n. So let's do a small example. The first one is a to the power 3 to the power 2 times a to the power 2. Now, when you want to do this one, first of all, you need to work out like this way. A to the power 3 times to the power 2 times 2a squared. Well, the first thing that you need to do is remove the bracket here. You need to remove the bracket. When you remove the bracket, we are going into the multiplication rule of the indices. This will be, or the bracket rule of the indices, which will be a to the power 6. So that will be the first step for you to do. And then you bring this expression down. We have 2a to the power 2. Now, you have two initial expressions. What you need to do is you are supposed to multiply. So check whether there are coefficients in front of a's. Multiply the coefficients together first. So here the coefficient is 1. So we need to multiply 1 times 2. We get 2. And then we need to deal with the a's. you can write like this, times a to the power 6 times a to the power 2. So there you have the two initial expressions combined together. We need to finally combine them together. We will get 2a to the power 6 plus 2, which will be 8. So that will be the final expression, the final answer for that. Moving on to the next question, we have 4x cubed y raised to the power cube. Now, if you want to do this one, what you need to do is remove the bracket again. 4x cubed y raised to the power 3. This is the same rule that we got here. We bring the power inside. So we are going to bring this power 3 outside the bracket in each of these numbers. We get 4 cubed times x cubed raised to the power 3. Remember, we have a cube here, so raised to the power cube, we will get another cube here, times y cubed. So, well, 4 cubed, you can multiply that, and then we will get 64, 4 cubed, 64 times x to the power 9. That is 3 times 3 is x to the power 9 times y cubed. So that will be the final expression. So we are using the multiplication, the bracket rules of the indices. We are bringing the power down or put the power inside to all of these expressions, and then we could finally come up with the solution like that. Moving on to the next slide, we have the following problem. Now this involves brackets, but still applies to lots of indices. So let's see how we can do this one. The first thing is that you need to remove the brackets here, step by step. Remove those two brackets by multiplication or multiplying out the brackets. So we get so this will be, when you remove the bracket, remove the first bracket by multiplying what is outside with everything inside. So the first term will be 6x squared plus, when you need to multiply this also, 2x squared with 5x, we will get 10x cube. And then with this multiplication, we will get minus 4x plus, remember, then we have to multiply these two. It's a minus and a minus. When you multiply, we get a positive x cube. Now, what is important to realize that the power of x there, it is 1. So when you multiply these two, we add the powers to get that cube there. Okay? So finally, we could arrange everything in order. So it's traditional that we always leave the highest power of x in the front. So we have here a 10x cube, and the next that will make us 11x cube. We get the next term will be 6x squared minus 4x. Okay? Let's try this one out. This is a fractional expression involving indices. Let's write it down. We have x cubed minus 2x divided by 3x squared. So the first thing is that we need to split them into two fractions. Here there is a large numerator with two terms, so we need to split them into two fractions like this. X cubed divided by 3x squared minus, we need to divide 2x also with 3x squared. So this is now the division laws of the indices. So we we are dividing x cubed with x squared. So division means subtracting the indices. We will get here the coefficient of x is 1, so we'll get 1/3 and 1/3 of x to the power 1. This is 3 minus 2 is 1. Minus 2 over 3. Now, when you divide the, you are going to get 1 minus 2, which is negative 1. So you could write it like this way also. Or if you want to go for a final answer, you could write 1/3 x minus 2 by 3 times 1 over x. So that's the way that we write x to the power minus 1, which is 1 over x. Or otherwise, you could write 2 by 3x. Right. Moving on to the next slide, we have the following problems. So let me address the first question here. 2a power 5 divided by here. This is the expression. So again, we have a power outside. We could do this in two ways. We could simplify what is inside the bracket first. I think that will be much better. So what we will write is 2a. We are just dividing what goes inside the bracket. We need to divide. So it's 5 minus 2, which is 3. So the final answer here is 2a cube raised to the power 2 times 3a. That makes much life easier for us. Now we will have to write, bring the power inside. We will get 2 power 2, which is 4 times a to the power 6. 3 to the power 2, which is actually what is happening is we are raising it to the power 2 like that. And then multiply with 3a. So we get here, there are few numbers here, we need to deal with them first. 4 and 3, we get 12. This will be 6 and the last one is a. So here we get finally 12a power 7. Right, the next one I will leave it for you as a practice example. Alright, moving on to the next slide, we have again a problem which involves brackets. So I'll leave this one to you. We'll do number 4 and let's simplify the following example. We have 2 to the power x times 3 to the power x. Let me write it for you. When you want to do this type of problems, we need to reverse the rules sometimes. There are some cases where we need to reverse the rule. Now, I think you have seen the last rule of indices, which was, let me go back to that rule. It says that a to the power ab to the power n equals to a to the power n times b to the power n. Now, this is something like the rule from the reverse application. So, we need to apply the rule in the reverse way. When we do it, we are going to combine these two powers into one single power like this. And so that means we will be able to write it like this way as a product inside a bracket 2 and 3. And then the power is a common power outside the bracket. That allows us to combine this into a simple whole number. That's 6. 2 times 3 is 6. Then we have still the power outside. So that would be the final answer for that. I'm going to take you to the next level of indices, which is the negative and fractional indices. Now, in the case of negative and fractional indices, the same rules for basic indices will also work here also. But the only thing is, you need to remember there are certain ways of writing negative indices. But first, let me give you some of the basic rules here. You may have seen this first rule, a to the power 0. That means anything to the power 0 is always 1. It could be a fraction also. Anything, a fraction to the power 0 is 1. Any number except 0, you should get 1 there. And There's something about the square roots that we need to know. For example, the square root of a number simply means it is the positive square root of that number. For example, square root of 9 will give you 3. It won't give you minus 3. Otherwise, what would be the use of the quadratic formula? In the quadratic formula also we get a simple expression like this. For square root, we get b squared minus 4ac, the square root of b squared minus 4ac. We get it like this. Now, what I want to tell you is that it is not, the square root of a number is not plus or minus. The plus or minus will be simply there in front of the square root. Otherwise, there's no use of this quadratic formula if you just simply say plus or minus. So what I'm going to say is that if you have square root of 9, you are going to write it like 3, like that, okay? But if you have plus or minus square root of 9, you will get plus or minus 3. That means when you want to solve for a expression like, for example, you might want to solve this equation. Okay, you might want to solve that equation. To solve that equation, we need to take square roots on both sides. We will get then x equals to plus or minus square root of 9. It is equals to plus minus 3. Okay, just simply a square root of a number will be positive and will be a positive number. Keep that in mind. We have another rule that specifies, we have a fraction here, a to the power 1 over m, which will be equals to the mth root of a. Okay. Now there is an exception to this rule, which is the half the square root. For example, if I'm going to write that in square root form, I shouldn't write the square, the 2 outside here. I should write only square root of a like that. That's the only exception to this rule. For everything else, you are going to write, for example, if you have fourth power or 1 by 4th of a power 1 by 4th, you are going to write it as a to the power 4th root of a. That's the way that we can proceed, except half. That's the only exception. We don't write the 2 there. Okay. Now, moving on, we have also a fraction n over m, which is the mth root to the power n. Well, I'll show some examples in a while. And the most important thing is that when you have a negative power, you're just going to divide it by 1 and write it as a reciprocal form. So, for example, if you have a to the power minus m, this will be equals to 1 over a to the power m. Okay. So you saw some examples before also. When I was writing x to the power minus 1, you could write this as 1 over x to the power 1. Okay. So it is, you have to divide that by 1 and keep that part as the denominator. Bring it, make it a positive power by writing the reciprocal. Okay. All right. Moving on to the next question. Let me do the number, the second one with you. We have a fraction raised to a negative fraction. Now, this is something that you need to address or be careful about. In order to do this type of problems, you don't have to think very much on the details of indices rules. Just keep this in mind. I'm going to give you some a quick tip on how to do this one. First of all, if you get a fraction with a negative power, and the power is even a fraction. What you need to do is flip the base part. The base is here 27 over 8. Flip that fraction upside down. Okay. So in other words, turn the fraction or flip it. So that we are going to get it as like this, 27 over 8 to the power minus 2/3. So we are going to get 8 over 27. Okay. So after you have flipped the fraction, you get 8 over 27, and then the next thing that you need to realize is that you need to you have a negative power. So the next step will be ignore the negative. Ignore the negative. So when I ignore the negative, I get 2 by 3. So keep the 2 by 3. Don't flip it or don't turn the fraction upside down. So you need to keep the same power but without the negative. You need to leave the same power without the negative. So now we must somehow find the prime factorization and continue as usual. Now the prime factorizations of 8. 8 goes into 2 actually. How many times? 3 times, right? So this would be 2 to the power 3 equals to 8. So I'm going to write this as 2 to the power 3, that is our 8 as an index form, and then I'm going to write 27 also in that way. You already saw it, 27. The least prime factor that it goes is 3, so we saw it was 3 to the power 3. Okay. Now when I do that, I have the 3 which is common to both. So I'm going to do a small trick on that. I'm going to rewrite this as 2 by 3 to the power 3. But still I have this outside 2 by 3 hanging on. So I'm going to put that also outside 2 by 3. Okay. So in this step also I need to put that 2 by 3. Now we now focus only on the index and try to come up with how we can proceed this. This is none other than the multiplication rules of indices. So we can say we can multiply the index. We can get 3 times 2 by 3, which will be 2. So we get 2 by 3 to the power 2. Okay. Don't worry about the fraction. Just keep the fraction and then write the power outside. So we get, when you remove the power, it becomes 2 squared. At the same time, you need to bring the power onto 3 also. 3 squared. So it will be 2 squared over 3 squared, which is 4 over 9. Take the third one as a practice problem and try it out for yourself. The next one, I'm going to recap the basic rules. So to recap the lesson, let me go over the basic rules first. So we have basic rules and indices involving negative indices. So I know that you have a lot of questions, but this is not a platform where I could address all of your questions. So I think your teachers, if you got any doubts, will be there to help you. If you get any questions, please feel free to address them to your teachers, subject teachers, and then clarify your doubts. In the meantime, thank you for coming today, and I wish you a very good day. Thank you.